Hello everyone. Today we'll be discussing the first term work of analysis and design of algorithms lab, that is Tower of Hanoi problem. So in the Tower of Hanoi problem, three towers are given to us with disks arranged in decreasing order from bottom to top in one of the towers. There are three towers A, B and C, and as you can see in the tower A there are disks arranged in decreasing order from bottom to top. Now the goal here of this Tower of Hanoi problem is to move all the disks from tower A to tower C. So in order to do this, we have been given an auxiliary tower called as tower B. So the condition here is only one disk can be moved at a time, and a bigger disk shall not be placed on a smaller disk. So keeping these two things in mind, or these conditions in mind, we need to move all these disks from A to C. There can be any number of disks. There can be one disk, 2, 3 and so on. The number of disks should be greater than 0. So this is the function, a C function which I have written for Tower of Hanoi. It's a recursive function. So I have passed three parameters to it. First is the value of n, then the three towers A, B and C. Now what should we do if n is greater than 0? If n is greater than 0, then call this function Tower of Hanoi recursively, n minus 1 A, C and B. Then we have a printf statement which says move the disk from A to C. Here it's written A to C. Then again this function has been called recursively, n minus 1 B, A, C. We will trace this out and we will see how the number of moves can be got by tracing this algorithm. Okay, so this is the tracing of the algorithm Tower of Hanoi. So the first, I've taken the n value as 3 over here. This is the Tower of Hanoi function call. N value is 3. Here it is A, B and C. So A, B and C, I've named them as Tower 1, Tower 2 and Tower 3. So if you check the function there, n is greater than 0. If n is greater than 0, then first is a recursive call which says Tower of Hanoi, TOH, n minus 1, A, C and B. So n minus 1, 3 minus 1 is 2, A, C and B. This is A, B and C. So here it is A, C and B. Next is a printf statement which says move disk from A to C. So A is 1, C is 3. So 1 to 3. Next again is a recursive call to the function. This is n minus 1, then this is B, A, C. N minus 1 is 2, B, A and C. Right. Next again, here again n is greater than 0. Condition is true. Again come inside, call the function recursively. Okay, so go on expanding till n value becomes 0. So here after this, when n value becomes 0, n minus 1 minus 1 becomes 0, stop the execution, and hence I get all the moves. So all these things in the bracket are all your printf statements here. So after expanding this recursive call like this, I'm going to get n value as 0. When I get n value as 0, I'm stopping the expansion. So these things in the bracket are all the printf statements. So 1 to 3, 1 to 2, 3 to 2, 1 to 3, 2 to 1, 2 to 3 and 1 to 3. So all these printf statements are the different moves that you need to make from one tower to another tower to move all the disks from tower A to tower C. First you have to, if the n value is 3, if the number of disks is 3, then first move from 1 to 3, then from 1 to 2, then from 3 to 2, then from 1 to 3, then from 2 to 1, then 2 to 3 and 1 to 3. So when all these moves are executed, all the disks which are present in tower A will be moved to tower C. So try out this program and execute and check. Now the next thing is to calculate the time taken by this function to execute. Now this is the posteriori analysis where we are implementing the algorithm and we are checking how much time this function takes to execute. So if you want to do that in a C program, follow these steps. Okay, there are some simple steps which you need to follow. First is write the entire program. I have just given you a function of tower of Hanoi, so write the entire program in C language. In order to use the clock function, or in order to calculate time, we need to use the clock function. So if you want to use the clock function, we need to include a header file called as time.h in this fashion. So hash include time.h. So this is a function call in your main function. So this is the function call in main. So I need to find out how much time this function takes for execution. So I'm going to place the clock before and after. So when I place it before, time calculation or the timer will start. After the execution of this function, the timer will stop. So this is the starting time and this is the ending time. So starting time I'm going to calculate by taking a variable called t, and this t, since it is going to hold the starting time, it is of the type clock underscore t. So t is equal to clock open and close bracket. After this, call the function in main. After the function call, we need to calculate the end time. So end time is t is equal to clock minus t. Now we need to display how much total time is. So total time is going to be with this particular formula. So have a variable, take it of the type double. So time taken is equal to, convert this variable t, which is of the type clock underscore t, convert it to double, divided by clocks underscore per underscore second. So clocks per second. After that, print this variable time taken. So once you print this variable time taken, it will display the time in seconds. This was about tower of Hanoi.